right? So in the figure here, we're given a plot of electrostatic potential along the z-axis, and we want to plot or sketch out the E field. So I'm not going to be able to do this perfectly without some kind of graphing software, but I'll do my best. And really, we just want to sketch out the relationship between the potential and the E field anyway. So this is probably not varying in a continuous way, but that's okay. And it might be at a bit of an angle. All right. I feel like I can't help but draw things at a bit of an angle here. All right, so there's my V equals 0. Okay. Yeah, so I'm definitely at an angle, but all right, maybe I'll resketch it just to see if I can make it a little straighter here. All right, I think that works. Okay. And this should go down to 0. All right, so then the real point here is if this is my potential, and if I recall, I like to use this little box here. So I can get from my potential energy to my force by multiplication by minus the del, or the derivative vector. I can get from potential to potential energy by multiplication by Q, the charge. And I can get from potential to E field by multiplication by my derivative vector. Now here I'm just talking about the Z direction. So my E field is just the minus derivative of my potential with Z. And so I can identify, and to sketch out my E field, I can identify a few key points. Also to get some values here, so this is given as 1, that's given as 0.8. So to get some values, I can use kind of rough estimations. So I believe the time, or the distance, sorry, in here is about 2 meters. So it looks like my delta V over delta Z in that region is, say, about 1. So I would presume that I'm going to peak out at about 1 in here, and go down to, now I haven't drawn it to the same kind of scale here, but it does look like over here, my delta V over delta X is about 0.8 to negative 0.6, so about 1.4 over about 2, so about 0.7. So I would assume my E field is definitely going to decline the same way as my potential is declining, but we just need to identify some pieces here so we can sketch it out. So first of all, at each of the turning points, my dV by dz is 0, right? So these are the points where my derivative is 0. and so my E field will be 0 at these points. And I'm going to do my best to try to drop these down to this lower plot, because these should be my 0 crossings, and it's going to guide my sketch. Okay, so these points will be my 0 crossings, and then I really need to just join them up in between. My maxima are actually going to occur where the 0 crossings are, but remember my E field is minus dv by dz, meaning this point here, so the derivative here will be negative, so this will actually be my positive. My derivative here is positive, so this will actually be negative. So my E field will be maximally negative here, fairly maximally negative, positive there, negative here, a little bit reduced, positive here, a little bit reduced, negative here, a bit reduced, and here will be a bit positive and negative. So here's my kind of my points. They've compressed a bit. I don't think it's supposed to be this time variance. There's supposed to be a time variance here, but there. So that's my rough sketch here. The real things that we should notice, or if you use the graphing software, you definitely would notice, is just well, the E field's the negative derivative of the Z, and so it's a bit shifted from the potential field, or from the potential. It crosses 0 wherever the derivative is 0, so at each of the turnarounds. And then where the potential crosses 0 is where our maxima are. And then the specific values would just be, well, this would be something like 1, and over here it would be something like 0.7 probably. But that's just a rough estimate. If you wanted to do it fully, you would want to use some kind of graphing software. And here there's no solution, so this is just incomplete.